Welcome to Peninsula Seniors Out and About. We're at the Western Museum of Flight in Torrance. Let's go see what Cindy has for us today.
Welcome everyone to the Western Museum of Flight. I'm Cindy Maka, the director. He has flown down from Washington State to share his insights of what it is like to do the test flying of these magnificent and enormous airplanes that have made the transition between giant surface ships and near-giant aerial ships. What is it like to fly massive cargo through the airways of the world? Ladies and gentlemen, the man who has done this, Jerry Weitz.
This was a very interesting project. The project started back in 2007 and really started before that. And it's a very unique airplane, as you can see, and certainly not the most attractive airplane they've ever seen as well. There were a lot of things that happened when people said, "What's this airplane?" And we said to people, it's really just the Oscar Mayer Wienermobile, just with wings. Maybe not so much, but at least it was a thought. So the whole concept of this airplane came to pass with respect to how do you build a 787? And more effectively, how do you develop the supply chain for the 787? You've got vendors all over the world. You've got two different build sites for the assembly of the airplane. You've got Everett, Washington, and Charleston, South Carolina. At that time, we had the 3, the 8, and the 9. The 3 never got built, and they built the 10 instead. So, in simplest terms, we had a lot of pieces that had to come together in many places. The 787 was built because of market need. Boeing doesn't build anything unless they think they're going to make money with it, or at least sell them. Making money sometimes is a benefit, but with respect to the 87, there were a lot of promises made that didn't happen because I don't think people really appreciated the whole depth of the program. New techniques, new materials, new engines, new flight controls, just a whole new airplane. So there were lots of different things that happened, and the market was strong to build these airplanes. We predicted that there were lots of customers. They sold like hotcakes. People wanted them. They had firm orders right at the beginning for 514 airplanes from 43 airlines. And there were more and more and more coming on all the time. But the airplane was progressing slowly. So at least the build cycle had to be as efficient as we could make it. So it was the most successful launch in history of the Boeing company. The schedule, as you can see, changed because they predicted the thing would fly in 2007. When did it really fly? 2009. It was supposed to deliver in 2008, delivered in 2011. In the meantime, airplanes were stacking up and stacking up and stacking up. So again, how do we get those pieces together? And one thing we'll talk about is the fact that there were sub-assemblies that came from all over the world. And we had to have the ability to ship those sub-assemblies to Boeing and do it efficiently. So as you can see, we had to build a very big airplane. We're going to certify this airplane? Is this going to be a restricted airplane? Is this going to be a limited use airplane? Is this going to be, how do we do this? They needed volume of 65,000 cubic feet. That's 3 times the capacity of a 747-400 and 50% more than an Antonov 124. If we shipped that material by barge, it would take weeks. So we flew it. We had less inventory that we had to keep on at the facilities. We had no corrosion issues to worry about with respect to hauling things by barge, if you would. That backup was always foreseen as a backup, and there are, believe it or not, docks at Charleston and at Everett, Washington that could handle a barge with parts. They were built just in case. So where did the parts come from? You can see they came from all over the world. We had the trailing edges came, and they were able to truck those. Thank you. The center fuselage came from Alenia. which is in Italy, near Naples. Forward fuselage came from Spirit in Wichita, Kansas. The main landing gear came from Kawasaki Heavy Industry in Nagoya. Leading edge devices also came from Spirit Wichita, the wing box from Mitsubishi Heavy Industries, Kawasaki did the wing tips, and Boeing Winnipeg, again, other parts were bought, and some parts were actually built by Boeing. I know it's amazing, what a concept. So, how do you move those many parts from that many people, building it efficiently? It's not easy. So, believe it or not, this is one of those legendary build or designs that came up more or less around a coffee table with a lot of wine. At least that's the legend. I'm not sure that really happened because nobody drinks at Boeing because it would be illegal. So the airplane was put together and we built a root structure, and how did we do this? How did we get these things apart? And you can see that it was somewhat convoluted looking on the right side of that slide, you see the little Nagoya parts coming out of Nagoya. In the center of the slide, the parts coming out of Italy. Yeah, fine. And then on the left side, you can see the hop, skip, and jump across the United States between Wichita, Everett, and Charleston. So we can kind of get a grasp of the size of some of these components. Those are big fuselage pieces. So where did we build this thing? Well, Boeing didn't have the capacity to build it. We were building 87s. We were building lots of other airplanes there at the time. So, guess what? They went to EGAT in Taipei. It's a Boeing flatbed. That's a pressure bulkhead. I'll talk more about that later. talk about that video now a little bit in detail. The donor airplanes were 4 used passenger 747s. 2 from China Air, 2 from Air China. That's a little confusing, I know. One's mainland China, one's Taiwan. That's interesting in itself. And they chose them for availability because freighters are really hard, or were hard at that period of time to really get. And they chose to use airplane because what the heck, we're going to take it apart so much anyway. There was no sense in trying to take a perfectly good brand new freighter and then cut it up. That's just doesn't make much sense. You'll notice that, and maybe it'll be apparent in some of the later videos, aerodynamics was not a big issue. Volume was the issue. You'll see there are hundreds of 1-inch round head cherry rivets all over that airplane. They're in the boundary layer, so it doesn't really matter. The airplane itself had a max takeoff weight, as you can see, around 800,000 pounds. Max landing weight, 575,000 pounds. Zero fuel weight, about 535. It's a pretty empty airplane. We used Struck 4056 Pratt & Whitneys. The radius of that structure that you saw at is 148-inch radius. There's a new pressure bulkhead. The pressure bulkhead we're talking about is actually just aft of the flight deck, just aft of door 1. The aft of the airplane is not pressurized. There's no need to. There's no live cargo. There's nothing there. It's weight. Get weight out of the airplane is the issue. We removed the winglets for an issue we'll talk about later. It's a 128-inch stretch. They removed the tail fuel, and we added a 747 SP tail because it's 60 inches taller, and with all of that structure ahead of the tail, we wanted to be sure we had good rudder, and good effectiveness for the rudder, good stability, lateral directional. There's no APU because the airplane is only going to go to Boeing facilities. It's only go to a fixed number of places, and so the ground support equipment is there. One less maintenance item. Diverts are an issue. The airplane does transit Anchorage with one of the loads, and nothing's coming off, so you don't need any cargo handling equipment. A very unique way of handling cargo, and we'll get to that in a bit too. The cargo handling power and swing tail power are all on the ground support side. It's a very interesting concept. There's the forgings for the hinges. There's 2 of these forgings. Each one is capable of 40,000 pounds. It's all done from a solid piece of steel, all molded, all put on there, and that's what holds the swing tail. This is the number 2 airplane rolling out, and it's kind of a picture of what it actually looked like painted. It looked much nicer painted than it did unpainted, but for Flight Test Bird was unpainted the whole time. If you look at the donor airplanes on the line, you'll see that the white area there is basically cut on the dotted line. That's the part that was cut out of the airplane. The bottom picture shows you the airplane with that removed in the factory floor, on scaffolds, getting ready for the installation of the structure. It's kind of the flatbed look. You know, if we could fly it that way, I'm sure Boeing would like to have done it. We could have probably put anything on the back then. So installing the upper deck was really a major effort, as you saw in the videos. The factory was really clean. You had the people, they had the equipment, and not to say they didn't struggle with the first airplane. We had design issues and engineering issues as well as manufacturing issues. Anybody that's been around this business for a while understands that and knows it's really hard to do it in your own facility. Try doing it in somebody else's facility. They're not used to our process, we're not used to theirs. We want it built to our process. They don't understand our process. English is a second language. Lots and lots and lots of different issues here that came up. But the learning curve was steep, but the learning curve was done well. Airplanes 2, 3, and 4 were really clean airplanes out of the factory. One of the things I talked about was the swing tail. The swing tail itself is problematic in itself because you've got flight controls that run through that swing tail, and you have to maintain rig. You wouldn't want to have to re-rig every time you landed someplace and loaded or unloaded cargo. So they solved that, and they solved it well. The airplane seems to hold rig. The large Heisker forklift there on the bottom, which is huge, by the way, is the power, hydraulic power for all the loader, hydraulic power for the swing tail, and any electrical power having to do with the cargo handling equipment. All comes off of that one rig. It's a monster. As you can imagine, swinging that tail off of a single point, jack point, and trying to maintain loads is really critical because you can bend a lot of metal with that big rig and that much mass. So there's software, fly-by-wire software in that tug, believe it or not, that manages all those loads and dynamics to make sure that as it swings, the arc is true and the loads are within limits. It's pretty cool. Somebody said, "Do you want to drive it?" And I said, no, I didn't want to buy the airplane. No. So the first flight was done in Taiwan as well. In fact, we flew 4 flights over there. There's those cherry rivets I talked about. This is a picture I call Darth Freighter. Really hard to get a picture of the size of this thing, the volume of that cavity. Joe McDonald, who was the chief pilot for the 747 at that time, and Randy Wyatt was the first officer for that flight. So one of the things that was important on this program was that the airplane needed to fly just like a 747. That one of the goals and objectives was no additional training. It's a 747. And from the flight deck it is. But how do you do that? And you sort out the issues that are not, or that are unique to the airplane, and yet allow anybody with a 747-400 type rating to fly the airplane. Really, the only issues that are apparent to the pilot are the issues that occur on the ground handling. And from the flight deck, you can't see what's behind you anyway. It's just back there. There's no access to that part of the airplane at all. It's totally unpressurized. In fact, when I talked about the swing tail, there's about a ½ inch gap all the way around that swing tail when all the locks are in place. Birds fly in it. It's pretty bizarre. It really is. I mean, there's just big vents in the floor that to basically take the air that we circulate back there. They maintain about 0.2 of a psi, just slightly positive pressure. That's just based because you do pump air back through there. So, kind of a new and novel approach. This is a service bulletin. This is not an STC. It's a special use airplane, limited operation to the Boeing company by a set number of crews, and that's it. It's used for the Boeing company. It's not for revenue, not for hire. It's just for transporting material for the Boeing company. Originally, it was operated by Evergreen, and then has progressed now to Atlas since Evergreen went bankrupt. And that's how it's operated today, is by Evergreen or by Atlas pilots. So the flight test program. So we had this wonderful plan, and as you can see from the green line there was the plan, and then from the magenta line or purple line is what actually happened, which really isn't too bad. If you figure the flight test average is about 20% over what's estimated because you find things. Fly rate, pretty high fly rate, about 58, I think it said 58 flights a month, something like that. Falls in the middle of a lot of the current programs, not as high as some programs, but certainly more than others. You can see here is that rate and where it falls. Large cargo freighter, the numbers in red, and the others are several different models. The highest flight rate basically was on the 57-300 program. That was an extraordinarily high flight rate, and I never want to do that one again. It's just too hard. You get too tired. Your people get too tired. Your engineers get way tired. And you see here the footprint, and you'll see that it's really pretty aggressive. We started in July and we finished in April. That's pretty impressive. And with the big slowdown items were, I won't call it flutter, we'll call it a large limited cycle oscillation. And we've seen LCOs in other 4.7 programs along the way and have had to solve them. We found the vibration on really the first flight, and then we flew it enough in Taipei to make it, we felt comfortable with it to ferry it over to Seattle at a reduced flight envelope. And then did a little flutter investigation straight out of the box in Seattle, and then we had to work on that issue, worked on other issues, other parts of the airplane, and then solved the flutter problem. So how do we do that? 2.2 hertz was the frequency of the issue. We saw it on the first flight with the rudder kick, and it tended to hang on. This is the lateral response at the seat rail. The top chart is before we did fixes on the thing. As you can see, from the input on the left side of the chart on the top, you'll see the rudder kick, and you'll see the structure start to ring, and you'll see that it's not very well damped at all. It wasn't on the order of catastrophic, but it was on the order of fatigue, and from a certification point of view, you can't have any oscillation or vibration in the normal flight envelope. So we had to solve it. We did. How we solved it was moving the load inboard, unloading the outboard span of the wing. So we reduced the outboard tanks 1 and 4 fuel by 50%. And we removed the winglets, and that unloaded the outboard section of the wing. And we moved that load inboard, and it seemed to solve the problem. It wasn't that simple. Anybody who's dealt with flutter understands that sometimes you do something and you create something else. But it was right at 0.86 Mach. Well, somebody says, well, maybe you just reduce the Mach by a couple of tenths and you're okay. I'm not sure what the agreements were with the FAA, but I think the FAA was pretty restrictive, and they said if you're going to build these airplanes and you're going to do just a limited flight test program, and then it's got to be as good as. So, believe it or not, that means the full envelope of the 747, which means for the endpoint at VD or MD, you got to be out at 9.7 Mach with the airplane. Getting this airplane to 9.7 Mach was really hard. Between 30 and 25 degrees nose down, full throttle, and you're coming down rather quickly, and you're accelerating rather slowly, and you're trying to hit the altitude at the point, and if I did this with my hands, the airplane would stop accelerating. So basically it was get there, make your input, and recover. People that have flown A6 intruders talk about the fact that the A6 intruder has no limiting Mach because you can't make it go any faster even if you're diving straight down. So I think this is probably in that same order. We solved it, we made it work. Could we have just maybe lowered the speeds a little bit? Yeah, I think it would have been a lot easier, but who knows what the agreement was with the FAA. I think Boeing had enough controversy on other parts of the 87, they wanted no controversy on this program. So one of the things we do is we also want to look at VMCG. We didn't know exactly how our lateral directional control was going to be affected in ground effect, and we wanted to make sure that the airplane was good for VMCGs that were nominal to the set of the 400. So I've got an interesting video here of 3 of the VMCG points building up from, we do these tests, we start out at a speed that is faster than VMCG. VMCG is defined as the minimum controllable airspeed with the most critical engine failed on an icy slippery runway, if you would. That's pretty rather simplistic. So we disable the nose wheel steering, so the nose wheel steering is just castering. So all you have is aerodynamic control of brakes for directional stability, or directional control. And then we fail the engine with a fuel cut because we want a real sharp fuel spike, or a thrust spike, and we fail an outboard engine. And we typically will just use one engine if we don't want to beat up 2 engines, we just beat up 1. Because when you cut the fuel at high power, it's going to compressor stall. And it's usually a pretty good bang and a big aerodynamic load inside the engine. So here we go. With 4-engine airplanes, we tend to continue the takeoff. With 2-engine airplanes, we stop. I'll talk about that later if there's any questions. This is at Edwards. Yeah, that's exactly right. On a Saturday, because you don't want to fog the runway at Edwards on a weekday because they get really angry. We go to Edwards because it's wide and it's long. And there's a big lake bed out in front of the airplane. This one's pretty mundane. But you didn't see anything at all, did you? So that was a good build-up point. Nothing happened. That was all good. Things are wonderful. So we go a little slower. One of the things that happens on these tests too is that you don't do VMCGs very often. And so we typically will do some training, and we train people so that they have at least seen them, so that when the next program comes on in 10 years or 5 years or whatever it is, that we have people around that have seen it. So you'll see the failure happen there. The airplane starts to skate. And then the rudder bites. We get enough aerodynamic control for it to come back. And you go on. So when you train, you have experience, or you gain experience. And how do you get experience? Any takers? Got it. Okay. So how do you get experience? From bad judgment. Okay. So it was talked about how you perform a maneuver, and one of the things you do is you talk about the fact that in the data there's a 1 second delay between the recognition and input. Well, when you do the test, you don't wait 1 second. But because if you do, it looks like that. You let the guys with the sharp pencils do the 1 second and factor that in. But we also have photographers that are out there because we video everything. So I think he thought better about his camera placement that day. For my Douglas friends, I once did a 3-engine takeoff at Edwards on another program many years ago, and the MD-80 was in flight test, and they had the wind station out at the side of the runway. And they were doing their stuff with the MD-80, and I was doing my stuff on a Boeing airplane. And so I do this 3-engine takeoff, and so it was a little fast on the application of the thrust on the outboard engine. And so, needless to say, I was traveling a little bit more sideways on the runway than I wanted to, a little further sideways. But I could see that it was getting better. I could see that it was going to be fine. But I put my wingtip vortex right through the wind station and the tent that the people were in. We were not popular. So the airplane was certified in May of 2007, and then we went into what's called F&R testing, which is loads and delivery of items. You prove, do the route proving, you make sure all the loaders work right, you do all those things. And that becomes a very big part of the program. So this is what it looks like in use. Looks nicer with a paint job. Here's the loaders. It's amazing to me when you stand inside the airplane and watch the load coming on and off, how fast it's moving when it comes on. I would have slowed it down a little bit myself, but these big loaders are amazing. These are all like space stuff. This is actually what the load, where the fuselage was designed around, was the wing. The wing is the most difficult load with respect to the radius. And the wing, there's also a fuselage section that goes on that load, and that's the heaviest load. It's interesting, composite does not look like aluminum. You saw that same area today, it'd be full of airplanes. So when we talk about the 787, we have to talk about this airplane. There are 1,464 present orders on the 787. They've delivered 882 airplanes. Each airplane takes 6 loads. At a rate of 14 airplanes a month, that's 84 loads a month, spread between 4 airplanes. And you figure that one of those airplanes is probably in a C check or rotating D check or something all the time. So there's talk of a 5th airplane. So far it's been okay. There's talk of re-engineering the airplane simply because Pratt & Whitney's got a later version of the 4056 that's got better specs. So that would all be helpful. And because fuel prices in Alaska have gone up, Alaska has for the first time started charging sales tax on fuel. And so a 4.7 full of fuel is being load. So they'd like to be able to bypass Fairbanks, or Anchorage rather. So that's a lot of airplanes. I mean, what if you could do something else with this airplane? I mean, maybe we should make it a passenger version. I mean, what do you think? So with that, I'm kind of open for questions, and I'm fair game. The program has been very successful. It's nice to say that, having airplanes be successful. Did we do any wind tunnel questioning? There was very limited wind tunnel. There was some CFD that was done, no wind tunnel. They figure the critical parts were good. Now, the flow around that crown skin, I think that's what you're talking about. There are doublers, triplers, and quintuplers up there. There's more aluminum up there than you can imagine, and for that very reason, because there have been Guppy airplanes that have had failures up in that crown skin area because the loads are extremely high. Is it noisy? Yeah. What is the cruise Mach? The cruise Mach is an 8.2 because it probably should be a little bit lower, you think? But time is more important than fuel. How's it do on gas? It burns it. Yeah. What's the difference in fuel between this and a 400 freighter? I would guess around 20 to 25%, if I recall. The question was with respect to how many flight hours did we put on the airplane. With the number of test items, I think I would agree with Pete. I would say it was in that period of time when we were flying at about a rate of 58 flights per month, and nominally it's 4 hours per flight, so it's probably about 240 hours, which is remarkably low. Because you didn't have to do a lot of things. Many items we didn't change, we didn't touch. Was there ever going to be a passenger version of the airplane? Never going to happen. And to also continue that question, was there ever planned to sell a commercial freighter version of the airplane? No. Okay, here we go. I was waiting for this. Hey! So questions about, the question has to do with how did, experience comes from bad judgment. So how did we ever get to the max? Okay. Now, this is Jerry White's retired Boeing for many years, did not work in the program. Not to say that I'm immune from conversations with other people at Boeing, but that's to say. Okay. So, there are many, many, many things that have happened, and I'm going to address it this way. Many of you may have seen the New York Times article that came out last week about the MAX. Okay? So, when I started doing flight tests in 1978, some of the things you do is what you call risk failure analysis. Okay? In 1978, there were many things I would call hazardous that in today's world I would call catastrophic. And the reason I would say that is because we have transitioned through, before me, silk scarf flying, if you would, to post-World War II, post-Korean War, Vietnam, blah, blah, barnstormer pilots, military pilots, so on and so forth. We transitioned through a time when automation was not so good, that autopilots were not 100%, that navigation was an art, to a time now when on my iPad with ForeFlight, I have 10-meter accuracy and excellent navigation and very easy, to autoflight systems that are so reliable that you use them all the time, to pilots whose initial response on takeoff is gear up, flaps up, autopilot on, to at 500 feet on landing or less, autopilot off. We have transitioned through a time where airline travel had a certain amount of risk in it, to a time that was not risky at all. It's the safest form of transportation anywhere. Even with all the stuff that's going on, it's still the safest form of transportation. We have made the automation so good that the airlines went through a time where they said, we don't want you hand flying the airplane. We want you to use the automation. It's a smoother ride. You're not going to spill the martini in first class. You're not going to knock some old lady down back by the aft bulkhead going to the lavatory. You know, all those sorts of things. Use the automation because it's better than you are. It's not that it's better than you are. In some cases it may be. But it's certainly more consistently reliable. The result is consistent. Until it doesn't work. And then you've got the situation where now we were all proud in my day of how well we could fly the airplane. We want autopilots, fan flew the airplane everywhere. The airplane was part of it. You wore the airplane. That's just who we are. To a time when we've been told not to fly it because we're going to hurt somebody. Something could go wrong, then the company's going to be liable, and oh my gosh, that's awful. Well, things started happening. Air France 447 was a good precursor to that. Indicated that pilots were not as good as they wanted, because if the pilots had done nothing on Air France 447, in 2 minutes the problem would have gone away. We have transitioned to a time when we have military aviators was the bulk of the people who flew airplanes, to a time when we've run out of those guys. We can't produce them enough. There's just not the demand out there anymore. Well, I'll get to that. So now we have ab initio academies worldwide. United States too. And we train people, say, and in some countries it's like, you have an aptitude for science or you have an aptitude for math, you're going to be a pilot. Now, what's their background? What's their transportation? Bicycle? Walking, taking the bus? Have they ever driven a car? Probably not. Maybe they have a computer, and they're probably pretty good on it. And so they have a great deal of confidence in what that computation or what those things can do for them. How do you teach them to fly? By rote. There are companies, and I've been there in the training simulators, where you go visit and you give them a malfunction on simulator flight number 4 that isn't in the script. They will stop the simulator and say, no, that's not in the lesson plan. They have no capability to problem solve. Is it true of everybody? No, it's not true of everybody. Some of them can. In order to sit in the right seat of an airliner in a lot of the world, including Europe, you can have what's called a multi-pilot license, which essentially is 200 hours in an instrument rating. You have to fly with an experienced captain. And so when things happen, you haven't had that bad judgment that gained you experience to do things. Now, and believe me, when things turn to crap in a lot of automated airplanes, you've got bells and whistles and lights and stuff telling you that everything's going on, and you are suddenly in a train wreck. You are suddenly overwhelmed by a whole bunch of data that your brain is trying to process and problem solve, and it's really hard to do. The airplane that could have been a poster child was Qantas. The Qantas 380 incident, how many years ago? Probably 5 years ago, something like that. I think they had an engine failure, as I recall, and it took out a bunch of systems, and it just so happened that there were 5 pilots in the cockpit. And the crew management that occurred was incredible, because they had ECAM messages that were just pages of ECAM messages. They had lights, they had multiple systems going down, and this stuff was not in the checklist. There was no checklist for what was going on. So they had to individually partition and separate and manage all of those things going on, and at the same time fly the airplane. And an Airbus is all automation. I mean, it is, for want of a better word, it's like flying a bucket loader. If you've ever operated a bucket loader on a tractor, that's what it feels like to me, because you make an input and it moves at the rate it's going to move at. So you can make a full column input and it's only going to move so fast, just like your bucket moving on your tractor. Dude, on a Boeing airplane, you put somebody in the ceiling. So I was used to, when the first time I flew an Airbus at Airbus's request, I was amazed, because I kept basically going bang bang with the flight controls. I was going to full inputs because I was just not getting the rate that I was asking for, based upon my experience. So that takes us to the other side of the argument. Boeing has always built pilot-centric airplanes. Airbus came in at a later date, and they built automated airplanes. for a very specific audience, very specific customer base. Boeing started to transition to that, they thought, with the 777, but really didn't until the 87. The 777 is really very conventional in the way it flies. You have things that help you out, but it's really a very conventional airplane. So, getting back to my strain here. So how do you solve this issue? What's the best way? So Boeing builds this airplane that, and Mike Stennett, so I'll say Mike Stennett because he was the chief engineer, and it's a direct quote in this Wall Street Journal, you can read it. It made the comment that the pilot is the ultimate backup. That's the Boeing legacy. We all, of my generation, if things started going weird and you didn't understand what the airplane was doing or the automation was doing, that was the move. Auto throttles off, autopilot off, fly the airplane. If they had done that in both the Lion Air and the Ethiopian incident, but they kept trying to solve the problem and kept reverting back to the automation that was flawed, and they couldn't handle it. They were overwhelmed. They were still trying to fly all of the air traffic controller's instructions. They never declared an emergency. And they were trying to comply with heading changes, altitude changes, and everything else when they just basically couldn't, and manage the situation. And the first officer was unable to really process the information and help his captain out. So that's kind of my assessment where it is now. Did Boeing have a design that maybe I wouldn't have happened on my watch? I don't know. At least I would have raised my hand. Should have been a voted system. Should have been at least a miscompare that gave the pilots more information. Every other airplane, and oh, by the way, the 737 is not the only airplane with an MCAS in it. Okay? It's a very common way to solve a longitudinal stability issue. But if you had the miscompare up there, you would have just said, oh, okay. They flew with stick shaker on, the Lion Air that didn't crash, same airplane that did crash, but the flight before, they had the failure, they solved the problem, they did the right procedure, and they followed through on it. Only because, again, the jump seat recognized it. But even with that, they didn't pull the breakers on the stick shaker, and the stick shaker was on the entire duration of the flight. Now, you may ask, why did they continue to their destination and didn't go back? So yes, folks, there's we're at a cultural transition in aviation is where we're at. And the indicators have been coming on for a number of years with loss of control incidents and that sort of thing. And where we're at now is a point where at some point Boeing is going to have to go to a clean sheet airplane. Now, is the MAX a bad airplane? No. No, it's not. Did it have a bad design? Yes. Should the people, did the crew need to know about it? I don't think the crew needed to know anything about it, because if they just followed the procedure, it would have been fine. Now, would have been good to at least pass that information on to say, hey, there are systems on this airplane that cause this and that to happen. Yeah. Did it have to be trained? Well, now it does. So, yeah. Experience comes from bad judgment. Knowledge comes from mistakes. Could you foresee any use of an aircraft like the large cargo freighter with respect to military application? Oh, yeah. Oh, yeah. The other company I work for, just up the street in Long Beach, has a long pointy thing that would be really easy to carry around to places that you want to launch it from, that be easier to carry in an airplane like the large cargo freighter. Oh, okay. So I work for Virgin Orbit. My other part-time job, I'm a typical flunky at a retirement. I don't do it well, and I need things to keep my brain going. So I work with Virgin Orbit. We just did a successful drop test of an inert rocket, and a rocket that is called R2D2, because people like sci-fi stuff up there, which is Rocket 2 Design 2, which is the hot rocket, which is with all the liquid hypergolic stuff on it, which is like having a Webb sitting 30 feet away from you on your wing. Is Boeing going to keep on with this 37? As far as I know, yeah, I mean, the max is the max. Okay, the max is what it's, I think, going to be the end of that 1955 design, and it's from the pilots that have flown it and have. An FAA pilot quoted to me that he thought it was the best handling 737 he's ever flown. What was my background? Okay. I was an airport bum, like a lot of people in this room. I hung around airports. My folks had a very limited budget, shall we say, none, for aviation. And so I worked for a crop duster, and I swamped through high school, and Vietnam was going on, so that inspired me to stay in college, or to go to college. And so I came out of college and went in the Air Force, flew KC-135s in the Air Force. Did that for about 5 years. I guess in '75, was asked, because of my background and because of some other situations, to go up to Boeing and participate in a new airplane program, AWACS. So I did what I called a 3-year interview at Boeing, flying AWACS through engineering test and radar tests, and flying with a Boeing pilot in one seat and an Air Force pilot in the other. Had a tremendous mentor. Jim Gannett was my mentor. Jim Gannett is, along with Tim Chisholm, wrote Advisory Circular 25-7, which is the Bible on how do you do flight tests. He taught me as much as he could, as much as my feeble brain would allow, about flying the 707 and about flying reversible flight controls and flying an airplane that had some really dark corners in its handling qualities. I mean, those vintage airplanes were not like today's airplanes, and you could get in places that you didn't want to go. How do I feel about having had the opportunity to fly essentially every Boeing aircraft from the Dash 80 to the 787? It's pinch me. This should not have happened. I was a guy that was never going to get to be a pilot. I was a guy who went to flight school and felt like all these other people had their Corvettes and I had my 50 Plymouth, or whatever. And that it was always playing, all I wanted to do was be a test pilot. That's all I ever wanted to do. But believed it was impossible. A whole other subject, had the opportunity when Boeing went to rescue the Dash 80 out of Pima. Had the opportunity of recovering that aircraft out of Pima. An airplane with DC generators and AC alternators, and that there was no book for, because the airplane had been modified so much that those stuff just didn't exist. It had been on a high, upper blown surface experiment, And so it had no leading edges, had just these monster flaps on it, and and exposed drive jack screws and balsa wood and speed tape and plywood, and it was a home-built airplane. I mean, it was every bit of home-built. And you got to take it to the Smithsonian years later. But having had that opportunity to see the changes in time and how at least the Boeing story happened, it's just remarkable. And it is like, sometimes it's like, are you, me? You know, not kidding, but the other one. Because it's just fascinating. I always took trips that went to places that nobody wanted to go because you always found something that was very interesting. You know, Ethiopia and Africa and Bangladesh and those things, because you learn. And going out in those cultures, you learn about how other people see aviation. You know, it's like, I remember being someplace and I wanted to go up to Kathmandu. And they had a flight that daily went up to Kathmandu. And then they'd put one of their airplanes in a rice paddy someplace between where I was and Kathmandu. And I'd say, well, maybe not today. So yeah, I mean, having those experiences teach you that all cultures are not the same. They're not bad cultures. They just don't have the same experiences. They don't have those things. But we are trying to build, we are an industry where we try to solve the problem globally, and one size fits all. It doesn't. Maybe Airbus is a better solution. I don't know. It's a good airplane. I don't like it. I don't like the way it flies. But that's just me as a pilot. It's Fords and Chevrolets, if you would. What the SP tail on the large cargo freighter, did they build it, or was it a piece of surplus? The answer is I think they built it. Is it more impressive from the cockpit or from the ground when you do something like a VMCG? Most of the time, it's more impressive from the ground. The last one, I can guarantee you, was more impressive from the cockpit. Also, they pulled the number 1 engine back as well, because they did reduce some of the lateral deviation.
So it would have been even more impressive.
If they hadn't pulled the engine back, they probably got off the runway.
Now you disconnected it, the power to the nose gear.
Yeah, but it's the FAR requires, or the data requires, that you simulate a slippery runway, and you cannot take any credit for nose wheel steering or braking. Was the 2.2 hertz oscillation coupling problem? Was that because of the tail? It may have been part of a contributor. 4.7 historically has had LCOs and various parts of the envelope. And it usually has to do with the wing loading and fuel loading. And so the fuel burn in the wing is very, very scripted in how you burn and use fuel. Can I explain the difference between LCO and pure flutter? Okay. So an LCO has limits. It's bounded. If you hit a tuning fork, you'll get a frequency out of that tuning fork of some frequency. And it'll be essentially an LCO. It's constant. It's a very pure tone. If you have flutter, generally speaking, if you have flutter, depending on the onset, many times you do not have time to even react to it because it's explosive. It's divergent. The amplitude is increasing and it's divergent, and pretty soon you exceed some structural limit and things break. Yeah, there's There's been incidents where people have found themselves in a parachute outside the airplane and wondering why. Did I ever wish that I had either afterburners or an ejection seat? I'd say no, really. I mean, I've had some pretty dramatic incidents, and I'm not sure it would have done me any good. And what I can tell you is that you're mandated by the FAA to put escape systems into new prototypical models of transport category aircraft. The likelihood of you being able to get out of your seat and get back to that, wherever that chute is unlikely. The likelihood of getting out of the airplane and not hitting something on the airplane while you're getting out is remote. Well, you try to mitigate the risk, absolutely, before you go do the flight. And you do lots and lots of research. You build up, you start small and you go bigger. And then sometimes you go to places where you've been before and discover that just because of the way you made an input, that suddenly it's not the same. There's a very famous picture on a wall of an airplane that I flew that was missing large pieces of the vertical stabilizer, where I had cleared the airplane for flutter 6 months before, and we went back after the fix had gone in for some fatigue things, and we almost didn't go flutter the airplane, but we decided, well, what the heck, we got the time and the schedule, we'll go do it. And my rudder kick was 20 pounds heavier than the previous kick, and we broke the airplane. How many hours were on the airplanes before they were converted? About 20,000 hours. Now, you have to also think about where those airplanes were and who was maintaining them, and the amount of corrosion that's in the airplane, and how good was that maintenance, and how good was everything that went along the way. And so, yeah, there was a delta between the airplanes. Each one of those airplanes was different. It wasn't like taking a brand new piece of sheet metal. You went in there and you said, okay, what do we got to fix? So they usually went in and did the AD work up front, and then they did the mod, which was, sometimes you say, like, well, you did the AD work and now you're going to cut it up. Maybe you should have waited, I don't know. So it would seem like it was simpler to build the airplane all in one place. Yes, is the answer. But we chose to build it up in many other places simply because Boeing didn't have the capacity, and they didn't, and there's a lot of economics involved in it, that building a physical plant, finding the right people, and they were looking for people with composite experience and companies that had worked with composites before. They went that route once they figured out how to make the supply chain work. I think there were probably some offsets that occurred, about some balance of trade offsets that occurred in that thing. Today's world, that's a huge part of how you build anything. Is if we're going to have international customers, we'd like to have the ability to do some training. Now, unfortunately, what you find is that when you go to somebody else's house, that sometimes more learning about your design occurs than you would like, and that maybe you don't have control of your documentation as well as you thought you did, because the rules are not the same in their house as they are in your house. And so that happens. What was my favorite Boeing to fly? I'm going to address that two different ways, because there's two. The 707 will always hold a soft spot in my heart. The 777 program was the best flight test program I've ever been involved in. We did it right. We delivered it on time, which was unheard of. We did tons and tons and tons of simulation through Ironbird and through big electronic simulator or cell simulation integration laboratories where you integrate the wire runs, all of the optics, all of the avionics. So we had flown the airplane in simulation for a couple of years before we flew the metal. And not to say there weren't problems, because there's always discoveries. First stalls I did in a 777 ended up on my back. We fixed that. But that program just was great. Now, and don't quote me on this, but I can also tell you that a very senior person, when the 787 program came along, said, we can't afford to do that again. Now, somebody would say if you had only done that again, you might have been closer to on time. You also could have said if you'd listened to your engineers and your designers and not to the marketers, that you would have realized that the schedule that you delivered on was pretty close to the schedule they told you it was going to deliver on. What do I fly on weekends? I'm like a lot of airport bums. I have a friend that has a 182. I've never owned an airplane because my wife has horses. In fact, we have a new horse coming that I'm going to name Skylane, as a matter of fact, because I could have bought at least 2 of them by now, but there you are. So, yeah, I fly a 182 on weekends. I live in a little town called Twisp, Washington, which is about 100 air miles northeast of Seattle. It's in the mountains. It's cross-country skiing mecca. It's 5 hours by car to get to Seattle. It's an hour by air, by 182. Except that you've got to go across some really nasty terrain, and in the wintertime, really nasty ice machine. So, yeah, it's a great place to live. And when people have asked me, why do you live there? And I said, because they said 850 people. Why do you live here? I said, 850 people. But I can drive to the airport and count on one hand the number of cars I passed in 90 miles. So is it schizophrenic? I come down here to work. You bet it's schizophrenic. I come in here and I usually will start laughing someplace in my drive to Long Beach that say, wow. And they think they're having a good time. So anyway, that's what I do. You know, and the beauty of being retired is you can say no to things, and the beauty of being retired is that you can say yes to things, and people come to you because I'm not through. That I've done a lot of things, and I've been able to transfer that knowledge as much as I can to people. I make suggestions. I don't give direction. I let other people give direction. And if I don't like the direction, I can choose to play or not play. It's not a bad place to be. And if it's too much like work, then I don't come. So, yeah. So that's me. That's who I am. That's what I do. I do some other DER work, but it's, you know, I feel like I've still can add 2 + 2 and get 4, so I'm okay. So, and occasionally I get to work with people like Pete, and that's always handy. And we've known each other for a great number of years, and he's had my back, and I've had his from time to time, and been able to live and tell about it sometimes. What's the Boeing design build process is what you're basically asking. There's the requirement. They take the requirements and they say, okay, what's the airplane look like that would do that. Many times they have an airplane they'll do a market study usually and say, here's this hole in the market where there's demand. And the aircraft that are filling that part of the market have these specs. Can we beat those specs given today's technology? And so they'll go that way. And then they'll do it's a paper airplane process until there's a customer. And then the board of directors has to agree to spend the money on going after that part of the market. And then the customers come in and they buy it. They put money in. Boeing is a business, and so they're not going to build anything that somebody's not going to buy. So they have to have pretty firm commitments. And so that's the getting started part, and then there's the design, the integration. What do you want that airplane to be? What type of systems? What's it going to do? And usually it's the aero that drives it, aero and propulsion. And then once you've got the aero model, and usually a wind tunnel, work up CFD to wind tunnel, and then to see if somebody has an engine that'll fit. Sometimes the engine companies have to build an engine from scratch. The engine programs are every bit as big as an airplane program. And in today's engines, probably every bit as complex and sometimes more. I mean, they're squeezing every drop of fuel that they can out of those engines now to make them efficient, and it affects operability and maintainability. Rolls-Royce has certainly found that out in spades on the engine on the 87. It's adversely affected the 87 for all the customers that have Rolls-Royce engines. So he said there was a comment, Leslie, that this large airplane flew just like the simulator by one of the pilots on the airplane. He said, saying that it just flew just like the simulator. Well, that may be true, and I think it did. I mean, it really was pretty transparent to the fact that it was different than a 400. That's other than the fact that it was difficult to make it go fast and it burned a lot of gas.
Thank you for watching Peninsula Seniors Out and About. I'm Betty Wheaton. See you next time.